So in the last part of this week's lecture, we'll be going through the titration formula and the dilution formula. And before we get through those two formulas, we just need to learn how to calculate one more type of concentration, and that's normality. Normality is abbreviated to capital N, and this is the concentration that's used only for acids and bases. Now, normality is not the same thing as molarity. If you want to calculate normality, you have to find what's called the number of equivalents and multiply that times molarity. Normality is a lot like the osmolarity formula. But in osmolarity, we were calculating number of particles. Now, with normality, we'll be calculating the number of what are called equivalents. So what's an equivalent? An equivalent is, or the number of equivalents is equal to the number of H's if you have an acid, or OH's if you have a base. Okay, so let's just get some practice doing this. How many equivalents do we have in each of these compounds? Here we have H coming first. That means we have an acid. All you have to do to find number of equivalents is see how many H's or OH's you have. In this case, for the acid, we'll find how many H's we have. There are 3. That means we have 3 equivalents. Here we have a base with 2 OH's, 2 equivalents. 2 H's, 2 equivalents. 1 H, 1 equivalent. You find these number of equivalents. It's as easy as that. But don't confuse normality with osmolarity. You'll get the wrong answer. Because you'll be calculating extra particles or extra things instead of calculating just equivalents. Okay, so why do we need to know how to calculate normality? This is what's called the titration formula. And all the titration formula is telling you is, at what point will your acid and your base neutralize so that your solution is exactly at 7.0 pH. So all you need to do to find, to use the titration formula is to calculate the normality of the acid times the volume of the acid, and then that equals normality of base divided by volume of base. This is not a tricky formula. The algebra is pretty easy. The only thing that's really tricky about this is identifying what is each one of the variables' numerical value in each of the problems. Okay, so let's do a couple of examples of this right from your homework. This is number 48. A 25.0 milliliter sample of H2SO4 required 29.2 mils of 0.50 molar NaOH to neutralize, or to reach the end point, or same thing. Calculate the molarity, that's weird, of H2SO4. Okay, make your table of knowns and unknowns first. Okay, so we're given this value right here. We're given a volume, because that milliliters is volume. So I know that's V something. But is it VA or VB? Well, we have to look. Milliliters of something. Is that an acid or a base? That's an acid. So that is VA. VA equals 25.0 milliliters. Okay, now we get some more information here. Required. Oh, that's another volume. Is that acid or base? Well, you already picked your acid, so it has to be the base. Just use a little process of elimination there. And that required 0.5 molar NaOH. So here we have the molarity. But is that of an acid or a base? Well, that's the base. So we can write that down. And now my question wants me to find the molarity of H2SO4, which is the acid. Now, this is kind of tricky. That's why I picked this problem. Okay, so let us set up our equation, write down our equation. NA VA equals NB VB. Okay, what are we needing to solve for here? Well, we're looking for MA, but MA is not in this formula. The only thing we don't know though is this NA. So we're going to start out by solving for NA. So that means we have to get rid of that VA. You're multiplying, so you want to divide both sides by VA. So you should get NB VB divided by VA. Okay, look at this. Before you plug in chug, you need to have normality here, not molarity. You have the molarity here of your base. So let's just quick calculate. So if we have the molarity of our base is equal to 0.50 and our base is NaOH, calculate the normality. How many equivalents do we have in sodium hydroxide? 1. And our molarity is 0.5. So that means our molarity, our normality is 0.50 normal. Now we can go back and put that into our formula. Yes, that number is numerically the same as molarity, but you have to make sure that you're going through the process. Because if you don't do it this time, you might not do it the next time when your number isn't the same. Okay, so here we have 0.50 normal. Oh, I apologize. Times VB is 29.2 mils divided by 25.0 mils. And you get for an answer 0.584 normal. How do you know that that's the unit? Because that's the unit you have to use in your equation. Okay, so now that we have that this is true. Our question wants us to give us the answer in the unit of molarity though. So now we have to convert back from normal to molar. Okay, so we write down this equation and we solve for molar. See how I did that algebra? Oh, brother. Oop, 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 oop. I can tell it's getting late because I'm making mistakes all over the place. I apologize. So this is what we came up with from our equation, from our answer from 2 slides ago. That's what we're going to put into this equation. How many equivalents should I have here? 2. I have 2 H's. So you should get 0.292 molar H2SO4. Do I have the right number of sig figs? 3, 3, oh, this one only has 2. This number only has 2. That means my answer can only have 2 sig figs. So you gotta really watch out for that stuff. Alrighty. Let's do another example. This is 49. A 20 ml sample of 0.18 molar HCl is used to neutralize 0.120 molar NaOH. Calculate the volume of NaOH. Okay, I'm going to do that first. If that's volume, is that base or acid? It's base. And that equals question. Okay, then let's start at the top here. 20 mil sample of, and then you have to sometimes when you're going through these problems, it's really tricky to identify what goes with what. So the best advice I can give you is read a number, read the word of, and then just keep going until you find the next chemical substance. So 20 mil sample of this. Is that acid or base? That's acid. Okay, and then we have a molarity, again of the acid. And then that last value here that we have is a molarity of our base. Okay. Now, before you go any further, you have to convert molar to normal. And in both of these cases, we have equivalent of 1 and 1. You don't have to show your work for this, guys. I expect you to be able to do this math in your head. So you can skip showing your work for this. If you're making some stupid mistakes though, or if you're unsure and you want to get partial credit for stuff, you might want to show your work, but you don't have to. Okay. Then let me set up my equation. NaVa equals NBVB. What am I solving for? And then if you write all those numbers in, you should get an answer of 30.0 milliliters NaOH. That's how you use the neutralization or the titration formula. Now, the titration formula is exactly the same as another formula, the dilution formula. The dilution formula is used when you have to use a stock solution to make a less concentrated solution. So here we're going to be using almost the exact formula. But in the dilution formula, the difference is that we're not using acids and bases. We're having two different solutions of the same substance. We're just diluting it. Okay, so let's do an example of how to do this. From your homework, number 35, it says calculate the volume of 12 molar HCl needed to prepare 400 milliliters of 6 molar HCl. Okay. Now the thing with this dilution formula is the ones are for the stock solution. The stock solution is always the one that's more concentrated because that's the thing that you can dilute. When you buy chemicals from labs, they come concentrated. So when you get like hydrochloric acid, if you order that, it usually comes as 12 molar HCl. There aren't a lot of good purposes for 12 molar HCl. It's very dangerous because it's very concentrated. Calculate the pH of 12 molar HCl and you'll see why. Sulfuric acid comes as, I think, 18 molar H2SO4. That's the stuff that is in battery acid that can burn your fingerprints off. Very, very nasty stuff. So when we use it in the lab, or when you have dosages of medicine that need to be diluted, the pharmacists will dilute their stock solution. It comes concentrated, so you only have to buy a little to get a lot of medicine doses out of it. And this is the formula that can be used. So the ones go with the stock solution. That's always the one that's more concentrated. The twos go for the new solution that's created. And this is less concentrated, we'll say. Okay, so now let's go back and look at that example. Okay, now Again, just like the titration formula, the trickiest part about this formula is deciding who's M1 and who's M2. Okay, the best way to do it is to make your, you can even do this here ahead of time because you know that these values all have to be filled in. And then it's best to just go systematically through each part of the problem. Okay, calculate the volume of HCl, of 12 molar HCl needed to prepare 400 milliliters of 6 molar HCl. Okay, this is tricky, so just be really careful. Calculate the volume of 12.0 molar HCl. We're given two molarities. Which one of them is more concentrated? Well, the higher number. Let's give that M1. So M1 here is going to be 12.0 molar. Then what's V1? Well, we don't know the volume of that. See, that volume of 12.0 molar HCl, that's what we're supposed to calculate. So that's what should get the question mark. Then everything else is just filling in the blanks. Okay. Solve for V1. And after doing all that math, I think you should get 200, but I second guess myself. Yep, 200 milliliters. How many sig figs should you have in this answer? Only 2. That 6.0 has only 2 sig figs, so watch that. Okay, now by the time you guys are able to watch this video, you'll see that it's quite a bit, it probably won't be until Friday morning that these videos are all uploaded. So what we're going to do is we're not going to have any new material for next week. That means you'll be off of lecture for Tuesday. I have to reassess what day I want all the homework in so that you can prepare for your exam. There's a midterm at the end of next week, week 4. So by the time you're watching this, I'm sure I'll have all of that hashed out, and I've sent you an email about all those due dates. It's really important that you make note of those new due dates because they're not the typical due dates that we've been having. And it's really important that you give me a call or if you have questions about when that exam is due. So be sure to contact me about that. Good luck.